Hey guys, so this is the 094 Exam 4 review video, all about factoring. So starting off in 5.1, greatest common factor and factor by grouping. If you have me, the greatest common factor, that's going to show up in problems, but that won't be the entire problem, other than if it's maybe like a 2-point bonus or something. But if it's kind of a 10-point question, I promise when you pull the greatest common factor out, it's not done. You're going to need to keep going. So we'll see that as we go through. So let me do a few factor by grouping problems. So these are the ones that have 4 terms. And what we do is we look and see what's common. We kind of do the cover-up thing and figure out what's common to the first two. In this case, it'd be a y. So I can pull a y out front, 2x minus 3y. I like to write down the 2x minus 3y because I know I'm going to get it again. And there it is. It's exactly what it's supposed to be. And that's actually making it a little bit maybe harder. It's the too easy, it's hard thing. So what we need is a 1 right there so that when I go and factor this out, there's something to bring it back with, which is this 1. And I'll show that here in just a second. So this is my GCF, 2x minus 3y, and then y plus 1 is what's left behind. And so what I was saying about multiplying it back is if I go 2x minus 3y times y, that's that piece. 2x minus 3y times 1, that gets me that piece. And if it had been this but opposite, then that would just mean this was a negative 1. So that's kind of the trick there. This next one, let's see, we got, looks like just x's on those first 2 terms. So I'll pull an x out front, and it'll leave behind a 3xy minus 4. Again, I should get another one of these, so I'm going to write it down, because that's kind of the nature of these 4-term problems. And writing that down helps me see, what do I multiply 3 by to get back to negative 15? So it's going to have to be a negative 5. And I just kind of distribute and check myself, and negative 5 times negative 4 is positive 20. So then there's my GCF, and then x minus 5 left behind. Okay, so for this next one, we can pull an x out of the first 2. And then if I'm going to get x minus 3 again, and again, right now, this looks nothing like x minus 3, but writing it down kind of helps me see it. So then I can do a plus 4a, it looks like. Because what do I multiply x by to make it 4a? X would be 4a. And then 4a times negative 3, there's the negative 12. And then that's my GCF. And x plus 4 left behind. Number 4 is a little interesting. So this one I can pull an x squared out of. And then that's going to leave, sorry, I need another one. And then to make that work, I need to take out a negative 9. And again, if you kind of distribute back, there's that negative 36. So we have, there's our GCF. And then x squared minus 9 is what's left behind. But this time, since I had a cube, it can go one more round, because if it has an x cubed, it can factor up to 3 times. And this one does. So we ended up with x squared minus 9. We hadn't seen this when we originally did 5.1, but now that we've picked these up in 5.4, we know it's a difference of cubes. So it's going to go x plus 3 and x minus 3. Okay, 5.2. So 5.2 is where the leading term is 1x squared, or there's a GCF that breaks it down to a 1x squared, or just the plain x squared like it shows. And so what we're doing here is we're just doing what multiplies to be the end and adds to be the middle. And so here we have it's multiplying to be a positive, adding to be a negative, so I know it's going to be 2 negatives. 54 adds to 21 isn't maybe the most obvious one. So I can always start the list, 1 and 54, and then it'd be 2 and 27, and then 3 and 18, and then 3 and 18 make 21. So if you can't spot the number, you can always just start doing division. 1, 2, 3 goes into, and you can eventually hit the pair that's going to make the middle work. So this will be x minus 3 and x minus 18. That one's a little easier, so set up our x's and then what multiplies to 56 adds to be 1. So it's a negative 56, so that means we need a positive and a negative, and our numbers are going to be 1 apart. So plus 8 and minus 7. Number 7, same basic thing, except now there's this y squared on the end, not a big deal. All you gotta do for that is throw the same way that we put x's up front, we just put y's in back, so then when we go y times y, we'll get that y squared. And I need two values that multiply to negative 100, add to negative 21. And so one's positive, one's negative, so they're 21 apart. So that's going to be a minus 25 and a plus 4. This one, when you first look at it, it's these ones are dangerous. So this looks a lot like a magic method problem because it leads with something that isn't 1. But 6 goes into 12 and 90, so it's really a much easier problem. But it's a huge bummer if you miss that GCF. So that'll be a 2, and then 6 goes in, I think it's what, 15? Yeah. And then this is what I was saying at the top of the video. At least on my exam, if it's a 2-point bonus, it could be a little GCF. But if it's a regular question, it will not stop there. This is going to absolutely go further. And so just to be aware of that, because this is like 2 or 3 points, and then this part down here, recognizing to keep factoring, is the other 7 or 8 points. So really expensive mistake. Separate x's multiplies to negative 15, adds to be 2, so it sounds like a plus 5 and a minus 3. Okay, so this one looks miserable, but it really isn't. It's just a GCF is making it look terrible. And so when I see that 3 out front, it really makes me hope it goes into this, and it does. And then it looks like I can take out an x squared and a y. It's my smallest power, and x is x squared. So 3x squared y. And that's going to leave an x squared up front. 3 goes into 54 18 times. And then x, taking 2 out of 3. And then 3 goes into 135 45 times. And so it looked terrible to start, and now it's just what multiplies to 45 and adds to be 18. So not nearly as bad. And that will be plus 3 plus 15. Next one, another GCF. So take a 3x out, leaves behind x squared minus 12x plus 27. And I need two numbers to multiply to be positive 27 and add to be negative 12. So that's going to be x minus 3 and x minus 9. And this one looks like a GCF of 4y. So x squared plus 5x minus 4 goes in 14, yes. And then multiplies to 14, adds to be 5. So that'll be a positive 7 and a negative 2. And last one of these, looks like I can get a 3x out of there. So x squared plus 2xy minus 3, and then y squared. So it's another one of those ones with a y on the end, so we just do 3x. And let's see, it's going to be multiplied to negative 3, add to be 2, so plus 3y, and then x minus kind of invisible 1y. Okay, 5.3 was magic method, so these are those ones that don't have squares on the ends and don't lead with a 1. And so remember our steps on that, and you can check them out in the notes. They're right here, or on that the flow chart. I have all the steps there also. But our first step is to factor GCF, which we don't have one this time. Second step is to go 6 times 4 makes 24, and then I need two numbers to multiply to be 24, add to be negative 11. So it sounds like negative 3 and negative 8. And then we'll go 6x minus 3, and we make that kind of extra 6 minus 8. And then from there, we just divide out that extra 6 wherever it works out. So it looks like I can do 3 of it right here and 2 of it right there. So then that's going to give us 2x minus 1, and here 3x minus 4. And I didn't say it at the top, but let me remind you that you can always check any factoring problem by FOIL. So if I FOIL this back, I get 6x squared right there. On the outside, I get 8x minus 8x minus 3x, that's minus 11, minus 1 minus 4, there's our plus 4. So when you're taking this test, you can FOIL and check yourself, and you can know if you have it right or wrong. Next one, same idea, but it's got, again, that extra letter. So 6 times negative 10 is negative 60, so I need two numbers multiplied negative 60 and add to be 11. So that'll be a 15 and a negative 4. So we'll do 6x plus 15, y, and 6x minus 4y. And then we'll just divide out that extra 6 wherever it works. So we could do 3 of it here, 2 of it there. And so that's going to go 2x plus 5y. And this side will be 3x minus 2y. Okay, so then we got some GCFs. So it looks like 14, 49, and 28, so those would all have a 7 in common. Plus I can grab an x out of there. So we'll do 7x, 2x squared, plus 7x minus 4. And then 2 times negative 4, so negative 8. So it's going to be an 8 and a 1 to make that positive 7. So then we got 7x, 2x plus 8, and 2x minus 1. And then I can divide a 2. And so it would cancel the 2 out and then just bring down the 2x minus 1. This one looks like a 10x squared that we can do. So that's going to be 10x squared plus 11x plus 3. And then 10 times 3, that's going to be a 30, so we need a 6 and 5. So we'll do 10x squared, 10x plus 6, and 10x plus 5. So then we have a kind of a fake 10 to divide out, so I can do 2 of it right here. I can do 5 of it right there. That's going to get us 10x squared, 5x plus 3. 5 goes in there twice, and 5 goes into 5 one time. Let's see, this one, 2 times 14, so negative 28. And so it'd be a positive 28 and a negative 1. Sometimes the thing with the 1 is hard to spot. So 2x and then minus 20, oops, I wrote that backwards. That should be that way, sorry. Minus 28y, and then 2x plus 1y, so I'll just write y. And then we can get rid of the 2 right here. And that's going to get us x minus 14y and 2x plus y. And then this last one, 20, 56, and 36. I think it's going to be a 4 is the best we can do. But that will help a bunch because we don't want to go 20 times 36 because that would be terrible. So 5x squared there, 4 goes into that, 14, sorry. And 4 goes in that one, 9. So now that gets it down to 45, which is much nicer. And we need 2 numbers to multiply to 45 and add to be negative 14. So it sounds like a negative 9 and negative 5. So 5x minus 9 and 5x minus 5. And then I'll just take out that extra 5 right here. I got 4, 5x minus 9, and x minus 1. Okay, 5.4 brought us factoring by special products. So these are the ones with the formulas. And again, they're in the notes, so I won't bother to write them out here. But it's the ones with the squares on the ends where they come out to a minus b quantity squared, or a plus b quantity squared. And that's the 3-term ones. And then there's the 2-term difference of squares, and that's our a plus b, a minus b. And then careful, a squared plus b squared is prime, does not factor. So careful not to fall for that one. So these are all 2 terms, so they're going to be the difference of squares, because we won't see cubes until 5.5, but that's kind of our other option. So here I'll take out a 2, x squared minus 9. And then x squared minus 9, that's just going to go 2x plus 3, x minus 3. Same idea here, 49 and 4, nothing common, but they are squares. So that's just going to be 7x plus 2z, 7x minus 2z. This one's sneaky, so I can take out a 2, and it gets me 4x squared plus 25. And that's one where you have to resist, because that's a plus, so you have to stop right there, because that's the one that's prime. And then this one, we can take out a 3x, so that's going to leave me an x squared minus 4. And then that's going to go one more round, 3x, x plus 2, x minus 2. Okay, so these are the 3-term variety. And so if it's a plus, remember it's a plus inside. If it's a minus, it's a minus. And then squares on the ends. That's how we tell these apart from the rest of them. So this should go 7x and then plus 2 quantity squared. And then remember our double check, and this is kind of how we foiled them out back in chapter 4. We just do 7 times 2 is 14, double that, and it should match the middle, 28. So to me, it's easier to pretend like these are what they look like and check them than it is to, do 49 times 4 and do it all out. So I'd encourage you to do the same. Over here, but you gotta do the check, right? Because it could have squares and not actually be one of these. So over here, it looks like I can do a common factor of 2. So that'll leave me a 9x squared minus 30x plus 25. And then there's those squares on the ends that make me think it's just going to be one of these. So I'll do 3x minus 5, because 3x times 3x, 9x squared. 5 times 5 is 25. And then 3 times 5 would be 15, doubled is 30. So I'm all good. Here, it's about the same problem, just written backwards. Okay, I'm not sure why I did that. 5. Yeah, it totally is. Okay, well, here it is again. So 25x squared minus 30x plus 9. So it's just going to be what we got, but the other direction. 5x minus 3 quantity squared. Over here, I can get an x squared out of the way, so let's do that. And then there's that taking x squared out of x squared, so careful that you get the 1 right there. And then 49 and 1 are both perfect squares, so let's try 7x and then minus 1 quantity squared. And so 7 times 1 would be 7, double it makes 14. Let's see, this one we take out an x squared again, and I get 9x squared minus 6x. I get it with the plus 1. So this will be x squared, and then 3x minus 1 and squared. And then this one looks all terrible, but it's really easy. So it's just 5x, minus makes a minus. 144 is 12 squared, so that would be 12r quantity squared. And our check, 5 times 12 would be 60. We got the xr, and double that, and it's 120. Okay, so now 5, 5 is sum and difference of cubes. So remember, that's these formulas, a cubed plus b cubed, and a cubed minus b cubed. And so this is where it makes the a plus b, and then I use the pattern to fill out the rest. And the signs on these, and I'll show that as I do an example. The signs, remember, go same, opposite, positive. So it's the same as what we start with. Oops, there we go. It's the same as what we start with here, and then opposite and positive on both formulas. So this one is just going to be 8x cubed breaks down to 2x minus 3, because 2x times 2x times 2x is 8x cubed, 3 times 3 times 3 is 9. What we're really doing is taking a cube root, we're just not calling it that. And then remember, the pattern to these is you just take the first one, 2x times 2x, that goes in front, 4x squared. You multiply them together, opposite sign, so plus here. 2 times 3 is 6x. 3 times 3 makes 9. Down here, so we need an x, and then 64 is 4 cubed. So it's going to be plus 4. And then x times x is x squared. X times 4, opposite sign, so 4x. 4 times 4 would be 16. Two terms, right? So, but there's a GCF going on, so that makes it a little bit harder to see what's up. So let's get a 2x out of there and see what that gets us. So we take a 2x out, and then we get 27x cubed, and then plus 125 z cubed. And so now we can see our cubes, so we'll just break those down. So 2x, 27x cubed would break down to 3x, 125z cubed would break down to a 5z. And then 3x times 3x is 9x squared. 3 times 5 would be minus 15xz, opposite sign. 5z times 5z will be plus 25z squared. And this one, again, with kind of the GCF in there, it's hard to see what's up. So we'll just get a 3 and a y out of there, and that'll leave us an x cubed minus 8y cubed. And then we can see our cubes and proceed. So 3y, x minus 2y, x times x, x squared. This multiplied together makes plus 2xy, and then 2y times 2y will be 4y squared. Okay, so that brings us to section 5.6, which was the first 5 sections all kind of mixed together. These first 6 questions are an example, just one of each of the styles we've seen, and I'll talk about how to tell them apart from each other. And then after that, they're kind of mixed up, sort of like they would be in an exam. So this first one, and this is all kind of going off that flow chart that we've been using all throughout this chapter. So the first one has 4 terms, so that means it's got to be a grouping problem. So looking at those first 2, I can take an a out of there, and that's going to leave me a 3a minus 1. And so I got to get another one of those. And that helps me see I need to pull a 5b, a negative 5b. So then negative 5 times 3, there's our negative 15ab, and negative 5b times the negative 1 makes the positive. So that's why I like writing that down, is because that's really hard to figure out what to do kind of without seeing where you're trying to get to. So 3a minus 1 comes out and leaves behind a minus 5b. This next one, it's got 3 terms, but there's a GCF going on, so we'll get that out of the way first. So x squared minus 14x plus 48. And that is 3 terms, and it leads with a 1, so it's section 5.2. This one was section 5.1. And so for this is the nice kind where we just set up the x's and do what multiplies to 48 adds to be negative 14. So that would be negative 6 and negative 8. Okay, next we got 3 terms, and it does not lead with a 1, and it does not have squares on the ends. So that means we're in section 5.3, so magic. 3 times negative 20, so that is negative 60. And we need 2 numbers multiplied, negative 60, add to be negative 11, so it's going to be negative 15 and positive 4. So then we do our 3x minus 15 and 3x plus 4, and we divide out that extra 3 right there. X minus 5. And then this just comes down, and that's it. So this one, it almost, you can kind of see the squares on the ends, but it's a little messed up, so it looks like we have an extra x floating around in there. So we'll do our GCF first. Always do that as a separate step. The people who try to do the whole thing in their head mostly get it wrong. 25y squared. And so now I really do have the perfect squares on the ends. This will be x, and then this is an a plus b quantity squared. So 2x plus 5y quantity squared. And so that was section 5.4. So then these next two are example of two-term problems. So for two terms, whether they have difference of squares or difference or sum of cubes. And right now, this doesn't look like much of, if anything. So once I get the GCF out of the way, then I'll be able to see better what's going on. So it looks like we can do an x squared and an a. So then that's going to leave us x squared minus 36. X squared came out, taking out 1a, so a squared. And now we can see our a squared minus b squared form. So ax, or x squared a, x plus 6a, and then x minus 6a. And then this one's going to be our cubes. So that's just that formula, 2x minus 3. So 2x, 2x, 2x gets us back there. 3 times 3 times 3 gets us back there. And then we go 2x times 2x, 4x squared, 2x times 3, opposite sign, 6x, 3 times 3, 9. Okay, so here's where we have to start kind of distinguishing between problem styles. So this first one has 4 terms, and so it's got to be a grouping problem. So we're going to do a 4x squared, and always beware cubes because they can go further. So 4x squared, and then this is going to be x plus 2. And then here I could take out a minus 9 to get that x plus 2 again. And then x plus 2 out front. And then the sneaky 4x squared minus 9 is what's left behind. But this is a 5.4 difference of squares, so I gotta go one more step. That's gonna go 2x plus 3, 2x minus 3. And, this could come out to be, 5x squared minus 9, and then we would stop because that would be prime. It wouldn't factor any further. But that one happens to be a difference of squares, so we do have to take it that last step. Number 40, so it looks like we can take out, I think a 2 is, and an x is it. So 2x, 6x squared minus 29x, and then 2 and 56 would be 28. So that still has some pretty big numbers. When I end up with big numbers like that, that's where I like to kind of go, okay, 6 times 28. So maybe if I break them up, I can see, because I don't really want to go 6 times 28 because that's something big. But maybe if I do this, then I can kind of see how to group them to make them, they're going to multiply. Whatever I make out of these multiplies to be the 6 times 28. But I need to add to be negative 29. So it's 2 negative numbers. And just sort of looking at it, here it is. So we got 21 right there. And then right there we have 8. So 8 times 21 is the same as this, and they make negative 29. So 6x minus 8 and 6x minus 21. And then we'll just do 2 there and 3 there. So 2x, 3x minus 4, and then 2x minus 7. Okay, number 41. So this is a little bit more reasonable magic method, but there is no GCF and it doesn't have squares, so I gotta do magic. 12 times negative 3 is negative 36, and then two numbers multiply negative 36 and add to be 16 would be 18 and negative 2. So this will go to 12x plus 18, and then 12x minus 2. And then let's see, we can do 6 out of this first factor and 2 out of that second factor. So So that's going to be 2x plus 3 and 6x minus 1. Here I see some squares, but I also see a lot of b's going on. So we'll get a b cubed out of the way. And that's going to give us 4x squared minus 44xb, and then plus 121 b squared. And so now we do have the squares on the end, so that tells us we're in section 5.4. So that's just the a minus b quantity squared. So this will break down to 2x, minus makes it minus. 121 is 11 squared, so this is 11b, and then quantity squared. Let's see, this one kind of looks like a cube to start, but we got to get the GCF out of the way. So if we get a 3x out of there, then it's going to be 25x squared minus 4. So it's actually a difference of squares. So 3x and then 5x plus 2, 5x minus 2. And then there's our cubes. So there'll be a 2x plus 5y. 2x times 2x is 4x squared. 2x times 5y, opposite sign, 10xy, and then 25y squared. Okay, number 45, yeah, there's a GCF, so we can get a 3 out. So I'll make x squared plus 12x plus 36. And then you can either think of this as multiplies to 36 and adds to 12, or squares on the ends. It's both. But either way, it's going to come out x plus 6. And you could write it squared or another x plus 6. Both of those are correct. And 46 looks like another magic. So that makes 30. So negative 2, negative 15. So we'll do 3x minus 2, and then we need the y because of the y squared, and then 3x minus 15y, and then we'll just divide out our 3 right here. So 3x minus 2y, and then x minus 5y. Okay, last section, 5.7 was then solving quadratics using factoring. And next quarter we'll find there's a couple more ways of solving quadratics when they don't factor. So for this, we're going to bring the 3x over. So I'm just adding 3x to both sides. And this is the too easy, it's hard. This totally gets people. They try to make it a difference of squares or something. And it's just an x. So x plus 3 equals 0. And remember, when we have the x out front, that's just x equals 0. In this, if we said x plus 3 equals 0, we'd subtract the 3 over, and we get x equals negative 3. So it's the 0 and the factor always just have opposite signs. 48, let's see, this is just a nice 5-2 factor. So multiplies negative 63 and adds to be 2 is going to be plus 9. And minus 7. And so x equals negative 9 or x equals 7. Okay, so then this next one's 4 terms. That's going to be a grouping problem. So we'll go x squared and then x plus 2 and then a sneaky negative 1, x plus 2. And then we'll take out our x plus 2. It's going to be behind x squared minus 1. And there's another one of those difference of squares. So we'll finish factoring, get x plus 2, x plus 1, x minus 1 equals 0. So this one will be x equals negative 2, x equals negative 1, and then bring it over, it makes x equals positive 1. Number 50, so here we just have to, it's not equal to 0 right now, so we just have to subtract that 24 over. And that's going to end up looking like this, and then minus 24. And then we have our equal zeros, and it's just like that number 48. So x minus 8 and x plus 3. X equals 8, x equals negative 3. And then these last two, so here, distribute the x. I guess I should say I'm trying to get into the form that those last couple problems were in. So I'm going to multiply this out and then bring the 28 over so I have it somewhere where I can factor it. And while this looks factored, sort of, I mean, it's factored, it doesn't equal 0. And if it doesn't equal 0, then the zero principle doesn't work. So we got to get the 28 incorporated. So x squared and then plus 3x. Oops, I don't know why I wrote that. Sorry, I was thinking of the 28 coming up. X squared plus 3x, and then subtract the 28 over, equals 0. And then it's just a regular factor from there. So x and x, and then plus 7 and minus 4. So x equals negative 7, x equals 4. And this last one, same idea. This one's going to be more of a full FOIL, and then I have to get the 1 over. So I'll just do this piece first. 2x squared, and then plus 2x plus 5x plus 5 equals negative 1. And then I'll go 2x squared and make this a 7x. And then adding that 1 over, make this plus 6 equals 0. And so then this one is magic. So 2 times 6 would be 12. So 3 and 4. So you have 2x plus 3 and 2x plus 4 equals 0. Divide out that extra 2. I actually don't need to when we're solving, but it's still a good habit. And this becomes x plus 2 equals 0. So here this is going to be x equals negative 2. And then this one, 2x plus 3 equals 0. And if you can see the negative 3 halves, that's awesome, but here's the steps. So we're subtracting the 3 over, and then dividing out the 2. And so x is negative 3 halves. And that wraps up the exam 4 review.